Good evening, everyone. Today, in this lecture, we are going to discuss the concept of gravitation. Look at now. To understand gravitation, just we want to know what is force. Force is an agency which, when acts on an object, then it tries to displace or displace the object. However, in the earlier classes, we know push or pull is called force. Push, just like pushing like that, or we pull like that, and we call it force. But actually, this is the definition of the force. Force is an agency which, when acts on an object, then it tries to displace or displace the object Now, in connection with the chapter of gravitation, just we want to know force of gravitation and force of gravity. However, at first sight, it looks like these two are same. In fact, they are same, but still customary there is a difference between force of gravity and force of gravitation. If we take any two celestial bodies, say two stars, two planets, one planet and their star, then the force of attraction between these two is termed as force of gravitation. But here, force of gravity is in between two bodies in which one of them is Earth, or we may call it near the surface of the Earth, the force by which Earth attracts anybody towards its center. However, as per the Newton's third law, we all know that the two forces between two bodies always acts simultaneously. However, in raw language, in a gross point of view, we call it every one of the action has equal and opposite reaction. But in my point of view, it is not so, because of the fact that if action, it takes some time to react. So how one can say that is the action reaction forces, Newton's third law? In fact, these two forces act simultaneously. So no way to say action reaction. However, customary we find in any text that action reaction pair. So in fact, that for Newton's third law, two bodies requirement is there. So every one of the action has equal and opposite reaction. So in this regard, here the forces between two point masses, in fact, here say the point mass m1 and here the point mass m2. Look at here, is the line joining. However, Newton's third law in two forms. One is the strong form, when the forces act line joining the center of the two bodies, or center of mass in fact. The strong form, and equal in this regard of magnitude, opposite in the regard of direction. But there is a weak form of Newton's third law. The forces on each other, not along the line joining the forces. However, these types of forces we will see in the higher classes, but in fact it is available in this form also. Look at now here, the force, first of all, M2 creates its field, and that field exerts force on M1. So in this class 9 and 10, if we call like that, there is a field and it creates in the universe, and the other object in this field experience something. So it is very lengthy, how one can say like that? No. What is the things? Just want to show the reality of the things here. But in gross point of view, force on M1 due to M2. But in fact, the reality is that force on M1 in the field of M2, or force exerted by M2 on M1, like that here. Line joining, strong form of the Newton's third law. So here, force on M1 in the field of M2, its magnitude turns out to be G M1 M2 over R square. F force on M2 in the field of M1 turns out to be magnitude same, direction opposite. Look at here, G M1 M2 over R square. This is the gravitational force. We all know there are 4 different types of forces exist in nature: gravitational force, electromagnetic force, nuclear force, weak force, and the 5th types of forces, we may call it in connection to the gravitational force, is that the a special type of attraction we will see later on. So here, so this is the forces, but in fact, as I mentioned here, is that this is the form of gravitational force, but in fact it is not so. Here is the force of gravitation, it turns out to be G infinity M1 M2 over R square 1 plus R over lambda alpha into e to the power minus R over lambda. So just I am writing this form of the Newton's gravitational force for the curiosities in you. Just want to create the interest of the subject. However, up to class 12, we solely use this formula, not it is so. But in fact here alpha is approximately minus 0.007 and lambda is approximately 200 meter. So alpha is here negative. Second term, look at here, second term is negative. It indicates the force is repulsive in nature. What we understand? The forces between two masses is always attractive in nature, of course. But this result came into existence in January 6, 1986 by Physics Review Letters. So now, for your interest, but we work with this formula. Okay. Now, second thing is that gravitational potential energy regarding this between two masses. So look at here, if we take reference point 0 joule of energy at infinity, then we write the formula like that here. Look at now here, potential energy U, this turns out to be minus G m1 m2 over R. This result valid only when if we take the reference point at infinity and the potential energy at infinity is taken to be 0 joule, of course. Now, the obvious question here is that this potential energy belongs to M1 or belongs to M2? Answer is neither belongs to M1 nor belongs to M2, but in fact, this potential energy is the energy of this system comprises the point masses M1 and M2. Okay. So, look at here, this is the now in a simpler form we like to write as G m1 m2 over R square. So, let G is the universal gravitational constant, value is already given 6.6 multiplied 10 to the power minus 11 Newton meter square per kilogram square. That's altogether different issue. It is the constant, universal constant, always given the problem. But look at here, there are 4 unknown, 1, 2, 3 and 4. If any 3 are given, then fourth one must be calculated from here. Okay, like that here 1, 2, 3, 4. G is universal constant. So, here also if 3 unknown are given, then fourth one may be calculated from this formula. Okay, that the things here. If 2 of them are given, say A for R, M1, M2, yes, we may calculate, but in terms of some certain parameter known as parametric solution. Okay, hopefully you will enjoy these short videos. Thank you.